This lesson is for Mrs. Cucci's College Prep Math class. We are on lesson 1.2, and today we're going to talk about estimation, graphs, and mathematical models. So the first thing that we need to talk about is what estimation is. Okay, so an estimation is the process of arriving at an approximate answer to a question. So approximate meaning it may not be exactly correct, but it'll be pretty close. Okay, it's an approximation or an estimation. Okay, so when we start talking about rounding and rounding whole numbers, it's just a little bit of review. When we round a whole number, we look to the digit to the right of the digit where we want the rounding to occur. So if a digit to the right is 5 or greater, we add 1 to the digit being rounded and replace all the other digits with 0. If the digit to the right is less than 5, we don't change the digit being rounded and we replace all the digits to the right with 0. And we're going to look at how that looks in just a minute. You're going to be seeing this symbol pop up, okay? It's like a curly equal sign. This means approximately equal to. Okay, approximately equal to, so not exactly equal, but approximately. All right, so let's do a little practice in rounding whole numbers. So we're going to round the world population of 6,751,593,103 as follows. So first we want to try and round it to the nearest million. So what we need to do is we actually need to find the number that's in the millions place. Okay? And I know that 1 million is a 1 with 6 zeros after it. So that's going to help me immensely. Here's 6 places right here. 1, 2, 3, 1, 2, 3. So this 1 right here is going to be in my millions place. All right? So from this 1, what we do is we look to the right. The rule was if it was 5 or above, we're going to bump it up. My daughter says 5 or above, give it a shove. Okay? And then everything to the right of that 1, which is now going to become a 2, gets bumped or turned into a 0. Okay? So when we round it to the nearest million, it's going to bump up to 752 million. So now let's try it to the nearest thousandth. So again, we have to find the thousandths place. All right, find the thousandths place. Let's do it in a different color. So we know we're ones, tens, hundreds, and thousands. This 3 right here is my thousandths place. Okay, so we look to the right. If it's 5 or above, we give it a shove. If it's below, we're going to leave it, and we're going to replace with zeros. So everything to the left stays. The 3 stays because the number to the right was less than 5. And now we make everything to the right 0. So we get 6,751,593,000. All right, so now let's try doing this with decimal parts. So again, ones, tens, hundreds, thousands, 10,000s, 100,000s, millions. Okay, so now let's do this with decimals. After a decimal place, we get tenths, hundredths, thousandths, 10,000ths, 100,000ths, and so on. Okay, so to the nearest hundredth. So we need to find the number in the hundredth place. Here's tenths, here's hundredths. This 4 right here is in my hundredths place. Everything to the left is going to stay the same. We're going to look to the right of the 4. If that number is a 5, we're going to bump the number up. If it's not, we're going to leave it. We look to the right of the 4, we get 1, so that means we're going to leave it and then fill in the zeros. Now, because it's a decimal, we really do not need these zeros, so this can just be written as 3.14. Okay? All right, let's try the next one, to the nearest thousandths. So we need to find the thousandths, tenths, hundredths, thousandths, that 1. Everything to the left stays the same. And we're going to look to the right of the 1, which is 5, which means that 1's going to get bumped up to a 2. And then we can replace with zeros, but again, we don't need them, so we can just write it like this. Okay. Estimation by rounding. All right, so you purchased bread for $2.59, detergent for $2.17, a sandwich for $3.65, an apple for 47 cents, and coffee for $5.79. The total bill is given as $18.67. Is this amount reasonable? Now, if you don't have a calculator on you and you're in the store, you're not going to want to take each amount to the penny and add it. So estimation really does come in handy here. So what we're going to do is we're going to estimate these things to the nearest dollar in order to give us a general idea. Okay? So when we're thinking money, remember, half a dollar is going to be our halfway point, right? 50 cents. So if it's 50 cents or above, we're going to bump up to the dollar. If it's below 50 cents, we're going to bump down. So if we look at bread, $2.59, right? That's going to get bumped up because 59 is above 50. So we're going to bump that to $3. Okay. 217 bumps to 2. 365 is going to be estimated as $4. 47 cents is going to be estimated at $0. Coffee is going to be estimated at $6. So if I take all those estimations, which are now really easy to add, I get an approximate number of $15, or a value of $15. So if I have $18.67, is 15 reasonable? Well, 1867 seems a bit high compared to 15. So personally, I would check my bill before paying it. If we were to actually take all these numbers and add them up, it would give us a value of 1467. Okay, so obviously this is going to be incorrect, but that estimation is really much closer to this value here than it is to what they're saying our bill is. Okay, so let's look at another. Estimation by rounding. So a carpenter who works full-time earns $28 per hour. We want to estimate the carpenter's weekly salary, and we want to estimate the carpenter's annual salary. So again, it's an estimation. So we're not going to really look at it being $28 per hour. What we're going to do is we're going to take that $28 per hour and we're going to estimate that to be $30 per hour. It's going to make the math much easier. Okay? So if we want to estimate the carpenter's weekly salary, we know that generally people work 40 hours per week. So we want to take our weekly salary, or our hourly salary of $30 per hour, and multiply that by 40 hours. Okay? So 30 times 40, or 3 times 4, is going to give me 12, with 2 zeros, $1,200 a week. Okay? So the next part of this is the carpenter's annual salary. So we know that there are 52 weeks in a year. And again, 52 weeks, that is going to make it kind of a difficult calculation. So let's take this and estimate it to 50 weeks. Okay. So we have $1,200 per week. And we want to multiply that by 50 weeks in a year. Okay. Those are going to cancel. 12 times 5 is 60. And we've got 3 zeros. So we're looking at $60,000 a year. And that's all by, again, that's estimation. Okay? All right, so let's look at some estimation with graphs. Magazines, newspapers, websites often display information using circle, bar, or line graphs. A circle graph is also not known as a pie chart. Circle graphs are divided into pieces called sectors. Okay, so this is an example of a circle graph or a pie chart. I'm pretty sure you've all probably seen one of these before. This is nothing new. Okay, so let's look at this question here. Applying estimation techniques to a circle graph. So according to the U.S. Census Bureau, in 2008, there were 220,948,915 Americans 20 years and older. Assuming that the circle above is representative of this age group, meaning it represents it or it shows information based on that age group, we're going to use the approximate information or appropriate information displayed by the graph to determine a calculation that shows the number of Americans 20 and older who, defined by old age, have a decline in physical activity or ability. Okay, so if we go up and take a peek at our chart here, I need to look for the sector that says decline in physical ability. So here it is. We've got a decline in physical ability right here. Okay, so I'm looking at this sector of 41%. All right, so if I want to know how many of this age group have a decline in physical ability, I want to know what 41% of that number is. Okay, and we did percentages this beginning of the half of the year, so this should be pretty simple for us. Okay, so 41% of, we know that we can't use 41 as a percentage, so we do have to take that and change it to a decimal. 41% of is multiplication in math, okay? 41% of this value here, my whole population. You could take out your calculator to find that. I'm going to plug that right in. Okay. We could find the exact value, but we're looking for an estimation. So let's estimate this to 40%. And let's estimate this to 220 million. It's going to make the math much easier. Okay. When I multiply 2 times 4, that's going to wind up with 88 million. Okay, and again, you can use your calculator for that. So that's the estimation. Now, this, obviously the estimate and the exact are going to be a bit different. So this is an estimation, which means I really should not be using an equal sign because we have estimated. I should be using an equivalent, okay? All right, so use rounding to find a reasonable estimate for this calculation, which I just did. Which is pretty simple. All right. So now let's take a look at a bar graph. Bar graphs can be horizontal or vertical, and their heights or lengths are used to show the amount of different items. Applying estimation and inductive reasoning to data on bar graphs. So that's what we're going to be doing in this problem. So we're going to use the data to the left to determine the following things. So a man's increased life expectancy rounded to the nearest hundredth of a year for subsequent birth years. Right, so yearly increase in life expectancy is about, there's my approximate sign, right? It's about the change in life expectancy from 1960 to 2005. Over the change in life expectancy, or the change in time, the life expectancy time from that same age or timeline. Okay, so life expectancy from 1960 for men to 2005. So in 2005, we had a life expectancy of 75.2. In 1960, we had a life expectancy of 66.6. That was over a span of time from 2005 to 1960. Okay, so we're looking at the total change in life expectancy. Essentially, we're kind of looking for that slope, okay? Change in Y over change in X. So what we wind up with is about, when I put this in my calculator, 0.19. And again, that's rounded to the nearest hundredth, tenths, hundredths. So let's look at the life expectancy of a man born in 2020. Now, if we look here, obviously, in 2020, I don't have anything to go off of. So we kind of have to do some calculations here, okay? So what we can do is we can say the life expectancy of a man born in 2020 is about, well, let's look at 1960. 66.6 plus, I know that we're going at about a slope of 0.19 for, let's say, from 1960 to 2020, that's 60 years. So what we've done is we've got our original point in time, we've got our slope, and we've got the number of years we're increasing. So when we multiply 0.19 times 60, we get 11.4, and that's approximately 78. So the life expectancy we determined for 2020 is about 78, and we use that by finding the slope up here. Okay. All right. Line graphs. So line graphs are used to illustrate trends over time. So these actually come up quite a bit, especially with things like population growth. So let's try one. The line graph above shows the percentage of high school seniors who have used alcohol or marijuana during the 30 days prior to being surveyed for the University of Michigan's Monitoring the Future study. Find an estimate for the percentage of seniors who used pot in 1990. Okay, so what we're going to do is we're going to go and we're going to look at 1990. Here it is. Okay, I want an estimate for the percentage of seniors who used pot. So pot is going to be my line in red, marijuana, right? So the estimate for number of students who used marijuana in 1990, I'm going to take and I'm going to look directly across. So to this value here, right? So I guess we could say this is probably about 14% of students. All right. In what 5-year period did the percentage of seniors who used pot decrease at the greatest rate? So we're looking for a 5-year period in which my graph has the steepest drop. Okay, where my graph has the steepest drop. So it looks like right here is where we wind up with that steepest drop. And that would be from 1985 to 1990. Okay, and which year labeled on the horizontal axis did 50% of the seniors use alcohol? So here's your 50%. And what year did that occur? So I'm going over from my horizontal and down. That's occurring in 1995. So these line graphs are actually pretty simple to use if you make sure you read the labels. Okay. All right, so let's take a peek at mathematical models. All right, so a formula is a statement of equality that uses letters to express the relationship between two or more variables. Okay. The process of finding formulas to describe real-world phenomena is called mathematical modeling. Okay? So that's another word you'll see for it. All right, so modeling the cost of attending public college. The bar graph in figure 1.7 shows the average cost of tuition and fees for a public 4-year college, adjusted for inflation. Estimate the yearly increase in tuition and fees, round to the nearest dollar. All right, so we want to figure out about how much it's going up every single year. So again, we're kind of trying to figure out the slope, okay, how it's changing. So just like we did for the last year, we could say the yearly increase in tuition and fees is about change in tuition from, let's say, 2000 to 2008. So 6,185, 3,362 over the change in the years, 2008 to 2000. All right. So this winds up being about 352.875, which we can approximate to 353. All right, so again, we found the slope, change in y over change in x, right? Here's y, here's x. So we're going to write a mathematical model that estimates the average cost of tuition and fees, T, at public four-year colleges for the school year ending in X years after 2000. All right, so T is going to represent our total cost. Okay, so T is equal to, let's say, my starting tuition. We started in 2000, right? So 3362. Plus the amount that it's going to go up every single year, which we just determined, 353 times the number of years. So what we did is we created a linear model to show the change. Okay, so that is today's lesson. So what you're going to do next is you're going to go on to that practice document. If you have any questions, please ask, and thank you very much.